Continue our look at fractions, and we're going to start operations on fractions. Now, the operation we're going to start with is multiplying. We're not going to start with addition because multiplication actually ends up being, I would say, conceptually easier to do. So if we have two fractions and we multiply them, the denominator and the numerator and the denominator, multiply across. So I get A times C over B times D. And so this pattern works nicely. So let's look at some examples and see how they work. So if I have 2/7 and I multiply it by 3/5, the top multiplies, and that gives me 6. And the bottom multiplies, which gives me 35. I have 1/11 times 1/3. The top multiplies to give me 1, and the bottom multiplies to give me 33, so I get 1/33. And if I have 2/3 times 4/7, the top multiplies to give me 8, and the bottom multiplies to give me 21. So multiplication from fractions is relatively straightforward. But what can happen is sometimes the multiplications want you to simplify before you begin multiplying. Now, because multiplication and division are related, and fractions are like divisions, we could say when we multiply these together we get a new top, but I'm not going to multiply it out yet. I get 3 times 8 over 4 times 11. Now notice these have shared factors. So before I even do the multiplication, I can realize that 4 goes into 8 twice, and I get 6/11. And this is going to come out in simplified form. So if we can think of these as being factors, we can look for factors that will be able to nullify each other. And if I kind of write my factoring out fully, if I use the prime factorization, 8 is 2 times 2 times 2, and 4 is 2 times 2. And so this prime factor and this prime factor and this prime factor and this prime factor really convert themselves into 1, and I get the 6/11. But sometimes you can recognize that 4 is a factor of 8, and so the 4 will go away and we can get a 2. And so I'll do another one involving factors of 2. And we could write out all the prime factors of 8. So 7 times 2 times 2 times 2 over 2 times 3. So these prime factors will become a 1, and I get 3 over 7 times 4, or 28. 3/28. Sorry, I had to pause there. Well, because multiplication can be strung about, let's add another multiplier to this. And we'll make it signed. 2 to the 7th times 3 to the 8th times a negative 14/15. Well, I have a positive times a positive times a negative, so my answer is going to be negative. So I'll put the negative sign out here. And now I'll write all the prime factors. 2 times 3 times 2 times 7. That's the prime factors of this, this, and this, multiplying across the top. And I'll now do the prime factors on the bottom. So I have 7 times 2 times 2 times 2 for 8, and 3 times 5 for 15. I still have my negative out front. these prime factors and these prime factors become 1s, and this prime factor and this prime factor becomes 1, and the 7 and the 7 become 1. So I have 1 upstairs and 2 times 5 left below at the bottom. So I have negative 1/10. Well, this can come out neatly with power rules. And so if I have powers, if I have A multiplied 3 times over B multiplied 2 times, right? Because that's what powers do, B times B, A times A times A. I want to multiply it by B over A times A. My upstairs will be A cubed times B over B squared times A squared. Now if I were to expand these out, this would be A times A times A times B over B times B times A times A. So 2 of these A's and 2 of these A's will go away, and 1 of the B's and 1 of the B's will go away. And so that gives me A over B. And there's a neat power rule that comes out of this. If I have the same base, so I'll just write it as B, to a power divided by the same B to another power, I can just subtract the 2 powers. So if I re-look at this, I can kind of adjust things here. So let's take this and look at it. I have 3B upstairs and 3A upstairs and 2A downstairs. So if I subtract the powers, 3 minus 2 is 1. So I get A to the first upstairs. Now I have B to the 1 and B to the 2. So if I subtract them, I get B to the minus 1. And this shows an interesting fact about negative exponents. Any base to a negative exponent is the same as 1 over the base to that exponent. So in this case, 1 minus 2 is negative 1, or that's the same as 1 over B to the first in this case. And so this power rule here will start popping up when we do divisions. What I tend to do, again, I'm going to look at the same thing, but look at how this rule really manifests itself. So this is what we got upstairs and downstairs. So I'm going to start looking at A. The bigger power is upstairs. So when I do the subtraction, the A is going to stay upstairs. And so 3 minus 2 is A to the first. The bigger power is downstairs for B. So when I do the subtraction, B is going to stay downstairs, and 2 minus 1 is 1. And so that's kind of how we use this rule, these power rules, is we see where the bigger power is, and we subtract the 2 of them, and the base stays wherever the bigger power was. So this can let us do some neat things. Let's just look in general. If I take the whole fraction to the 4th, that's the same as taking the upstairs to the 4th and the downstairs to the 4th. All right, so let's write it out to see why that's happening. So 3 to the 4th is the same as 3/4 to the 4th is the same as multiplying this out 4 times. And so the upstairs becomes what? 1, 2, 3, 4 multiplications of 3. And the downstairs become 1, 2, 3, 4 multiplications of 4. And let's see, 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3. So 27 times 3 is 81. And 4 to the 4th, I think I'm going to have to write this one out. 4 times 4 is 16, so that's 4 squared. 16 times 4 is 64. So that's 4 cubed, right? 1, 2, 3, so I need one more. 64 times 4. 4 times 4 is 6. Carry my 1. 256. And we've already expanded the factors, and there was nothing to cancel, so we know this is in simplified form. Well, the same thing can happen with negative fractions. Because this is an even power, this would be a negative times a negative, so my answer is going to be positive. And that gives me 2 squared over 5 squared, or 4/25. Now, to work with division of fractions, we're going to have to look at something that came from our definition of division. So if we go back, we defined the definition of division of A divided by B, definition of division. We can turn to a multiplication. We can turn it to A times 1 divided by B. And this thing here is called the reciprocal. Now, reciprocals do something. Let's look at this if I'm just going for, let's say we'll do 10 divided by 2. So I want to turn this into a multiplication. 10 times 1/2. Well, how do we get that? So if we think about what happens here, this is 2 over 1. And what happens is it gets flipped upside down. So we can think of 2 over 1, its reciprocal is 1/2. Well, let's think about it. 10 divided by 2 is 5. Well, one of the words we had for multiplication is of. And I can say 1/2 of 10 is 5. So multiplying by a fraction is like dividing by the denominator and then multiplying by the top. And so division and multiplication are really the same thing. Just note that b can't equal 0 because we can't divide by 0. It's not well defined. So we can find reciprocals from different fractions. What the reciprocal actually does is if I take a number and multiply it by its reciprocal, I get 9 times 10 over 10 times 9, 90 over 90, but that's 1. And so there was the other definition we had, the identity of multiplication, that said a times 1 over a equals 1. And again, this is the reciprocal. If I take my number and divide it into 1, multiplying will get me 1. In a fractional form, the reciprocal means we flip the fraction. So if I have the fraction 1/11, the reciprocal will be 11 over 1. And I can check that because 1 over 11 times 11 over 1 equals 1. So the reciprocal's job is to really change divisions into multiplication. And because we can do that in fractional form with the reciprocal, we can use that to help us divide fractions. So if I have some fraction, a over b, divided by another fraction, c over d, I can use the reciprocal in the definition of division to turn it into a multiplication. So the first part stays the same. I'm going to turn it to a multiplication, and I need to get the reciprocal of this. So I'll change that to d over c. And so I'm able to turn a division into a multiplication. With fractions, this becomes very useful. So let's look at some examples of this and take our time and just kind of notice the reciprocal and how it works with things. So 4/5 divided by 1/8 is equal to 4/5 times the reciprocal of 1/8. And that's 8/1. And if I do the multiplication on the tops, that's 32/5. And this is an improper fraction, so we'll do the division to turn it into a mixed number. So 5 goes into 36 times with 2 left over, so I put that over the original denominator. So I do my division, there's my remainder, and there's my original denominator. All right, let's do division with a negative fraction. So I'm going to divide 14/7 by -2/5. I'm going to turn this into a multiplication of the reciprocal. So the first part stays the same, and I'm going to multiply it by the reciprocal, -5/2. Now I'm going to look to simplify. 2 goes into 14 7 times, and so this is a negative times a positive. I'll have a negative. 5 times 7 is 35. And 1 times 17 is 17. Again, this is this is an improper fraction because the numerator is bigger than the denominator. So divide 17 into 35. It's still negative. 17 goes into 35 twice, which is 34, which leaves me with 1 left over. And so I get 2 1/17. So see how all the little bits that we have done before are coming together to make multiplication work. Well, this can even work if we have variables in the fraction. So if I have 3y over 4, we can think of this as 3y divided by 4, or we can think of it as the fraction made up of 3y quarters. Right? That's the nice thing is the pattern in numbers doesn't care if this is a fraction or a division. The number pattern will always do the same. We create them by doing the act of dividing or looking for things that are fractional patterns. So to the numbers, this makes no difference. And so I'm going to divide it by 5y cubed. So I'm going to turn it into a multiplication by keeping the first part and multiplying by the reciprocal. Now, this is over 1, because anything can be over 1. So the reciprocal will be 1 over 5y cubed. Now, downstairs I have 3y, and upstairs I have 1. So my y is going to be downstairs, and it's going to subtract power, so 3 minus 1, it's going to be a y squared. Upstairs I have 3 times 1, that's 3, and 4 times 5, 20. And so the thing that we end up wanting to keep doing is really make sure that our numerators line up and our denominators line up and our operations go across. Now we'll get to a point eventually where we will see divisions of fractions that are written like this. And we can look at the fractional bar here as a division. And so there's 2 ways we could look at this. We could look at this as 3y divided by 4 over 5y cubed. And so if I turn that into a multiplication, I get 3y times the reciprocal of 4 over 5y cubed, which is 5. I want to make sure I have everything right. I think I have my line in the wrong place. Oh yeah, the fraction's upstairs here. So let me go back here. I have the fraction 3y to the 4th. Whoops, change my color scheme here. 3y divided by 4. And I'm going to multiply it by the reciprocal of 1 over 5y cubed. So the same thing, writing an extra fraction bar here. I have the fraction upstairs. Sorry, I divided that down. All right. Let's continue looking at what we can look at here. Let's look at how this works out in reality sometimes. So I'm going to use the problem again in the slides and explain the points in it. So Cedar Point Amusement Park in Ohio has 72 rides. Of the 72 rides, 2/9 are roller coasters. And so we want to know how many are roller coasters. Now, what happens is when we have a ratio like this, it's saying 2 out of every 9 are a roller coaster. So if I divide 72 by 9, that's going to tell me how many collections of 9 there are. And whatever that answer is, I multiply by 2, and that's how many are roller coasters. But what's really nice about ratios like that is I can say 2/9 of, and I'll use multiplication for of, 72 would be the total number. And I'll write 72 as a fraction. And so I have 2 times 72 over 9 times 1. But if we know 9 goes into 72 8 times, and 2 times 8 is 16. And so 16 roller coasters in Cedar Park Amusement Park, Ohio. So that's how fractions can be really useful, is they say for every 9 things, 2 of them are roller coasters. And if we think of a fraction as 2/9 of, it becomes a multiplication. And this saves us from working this problem as 72 divided by 9, which will give me 8. And well, every 2 of those, two of those are roller coasters in such a way that we get this. Right? This is kind of how the words come out. 2/9 are roller coasters, or 2 out of every 9 are roller coasters. But writing 2 out of 9 as a fraction lets us do this as a one quick multiplication, or at least organize the multiplication. All right, that was section 3. We will continue onward through our chapter 4 discoveries.